On a standards body called the MIDI Manufacturers Association, and they're the people who are responsible for maintaining and developing and promoting MIDI, the MIDI protocol. So MIDI is sort of out there in the world. It has been since 1983 or so. It's free for anybody to use, and just a network of people who make MIDI-equipped gear volunteer their time to continue development and expand and sort of come to create standards within the industry so that everything continues to interoperate and work well together, and so that there can be an official new MIDI message, everybody knows how it works and what it does, and everybody can go out and make cool pieces of gear that talk to each other and do new things. And so MIDI 1.0 is 35 some years old now, and it's in billions of devices now because it's in web browsers and on phones. And it's baked into Android and iOS and all of these things, which is awesome because it means that so many different devices can communicate with each other over so many different platforms, and you can make music across a really wide spectrum of technologies and places and times, and it's super awesome. But it's also probably the oldest, among the oldest protocols commonly still in use in the world, and it's kind of run out of room for expansion.
So, is that long enough for you?
Seems to be.
Do you want me to move that synth out of the way then?
Maybe.
Let's do that.
I mean, it's more squared up on the top. Wait if you need it.
All right, maybe. Let's see. So in my role as a member of the Technical Standards Board of the MIDI Manufacturers Association, I've been involved in the development of MIDI 2.0, and I can give a little bit of a backstory about this. This, by the way, one of my colleagues in the MMA, Mike Kent, is actually one of the principal developers of MIDI 2. He's also the person that defined USB MIDI standard 10 some years ago. So he is a super knowledgeable MIDI cat, and he's also a member of his local Vancouver Synth Club. And so he put together a slideshow for that back in November, and when I said I was doing this, he said, "Hey, do you want my slides?" So he kicked me over a slideshow that I did not create and have nothing to do with, and have briefly glanced at. It's got a bunch of superfluous stuff in it, so we can skip over some of it, and I'll try to get to the juicy bits of like what's actually new in MIDI 2. But just a little bit of backstory about MIDI 2. It has been in development for probably 11 or 12 years now. And it was originally called the HD protocol. That was not what anybody was going to, it was not going to go to market called HD protocol, but that was the working title. So people that have been following this or paying attention at NAMM shows for the last decade might have heard rumors about some HD protocol or there's going to be a new MIDI, and it was like a Sasquatch or something, that like there were just rumors of MIDI 2 in the wild for a decade. And then finally, about 2 years ago, the major Japanese companies, MMA I should mention, the MIDI Manufacturers Association is everybody who makes MIDI gear in the world except for China. And China has their own equivalent organization for Korg and Roland and Yamaha and Kawai and Casio and all of those companies. And it has a different acronym. It's called AME, which I forget what it stands for exactly. But it's the Japanese MIDI Association. And they, so those big Korg and Roland and Yamaha account for between them an enormous percentage of the market, especially for digital things that have MIDI. And so if they're not hot on an idea, it's not going to get very far because, just because of the scale at which they operate. So one of the things that was keeping a replacement for MIDI permanently in the future was the fact that these enormous Japanese companies had spent millions of dollars over decades to educate people in MIDI. They had MIDI Pro certification programs and this huge ecosystem around MIDI that was super important to them, and they were not immediately on board with anything that was going to make that obsolete or redundant or like a loss for them. So in the course of developing MIDI 2, what became MIDI 2, it finally, originally the idea was, great, MIDI has served its purpose, we're gonna shoot for the moon and do everything, and it's gonna be amazing, and we will no longer be encumbered by the weighty chains of this ancient protocol. And the problem was, a lot of people really like a lot of things about MIDI and are not eager to, to toss it out. So about 2 years ago, seismic shift in the development of MIDI 2, which was maintain backwards compatibility, basically. Make it an evolution, an extension, an outgrowth of MIDI that still is fundamentally MIDI flavored and uses MIDI, and somehow managed to do that in a way that still allows you to really attain, a next level of performance, but without losing all of that good MIDI stuff that everybody's super invested in. And so ultimately that has come to pass over the past couple of years. There's a mature developed protocol now that, and not just a protocol, but sort of a whole system, which I'll go into, that does all that good stuff. And I may just fast forward through a bunch of slides here. This is history. The past has happened. MIDI existed. It has been used in many places, including the venerable Sound Blaster card. Thank you very much. I enjoyed that one. Yeah, USB MIDI is a thing and has been for about 10 years. It is marginally faster than 5-pin DIN MIDI, but it is perversely speed limited basically to 5-pin MIDI speed, because not every piece of software can support higher speeds, and there's no way to tell what speed you're going at, because there's not a word for that in MIDI. There's not a concept of bandwidth in MIDI, so even USB MIDI that could be better than what we have today is artificially limited because of the constructs of the language itself not having a way to support the concept of how fast you can go. So that is one thing that MIDI 2 also looks to address. MPE is a recent development. I was actually pretty closely involved in the development of MPE a couple of years ago, along with one of my colleagues at Moog, Eric Bevan, a bunch of people from Roli, and it was a really cool cross collaboration, across continents and across the industry, and it's really cool. And just about the time that MPE is, I think, really starting to take off, MIDI 2 may render it virtually obsolete, or at least, it's a superset of everything that MPE can do, that if you're using MIDI 2, you kind of don't need MPE. But it's like a transition. It's like a bridge that pointed us in the direction of MIDI 2. So this table is just showing, each of these little line items on this spreadsheet that's basically illegible because there's so many things on it. Each of those is an update to the MIDI 1.0 protocol, another document that the MMA voted on and approved. And so basically the idea is that the MIDI 1 protocol has been expanding for 30 years, and it's got a ton more stuff in it, but it's full. There are no more new opcodes to define new concepts, and the rules work a certain way, and it's like this, almost completely worked jigsaw puzzle where your options just get exponentially fewer and fewer, and you can't move around. So, yeah, this is a recap of what I was just saying off the top of my head. Future MIDI Expansion was the code word for this before there was an agreement across industry to call it MIDI 2, which was a whole debate. What do we call it? And MIDI 2 is so logical that eventually it kind of just won, because why would you not call it MIDI 2? All right, so the first of the pieces of the MIDI 2 puzzle that I was talking about, MIDI capability inquiry. This is a technology that lets devices talk to each other and say, hey, do you support X functionality? Or, what capabilities do you have? And so your MIDI router and your MIDI keyboard, you plug them in, they can negotiate. Keyboard says, hey, I'm a keyboard, I got this many programs, this is my synthesis model, I support these profiles that define a set of controls and parameters, and then your router or your DAW or whatever can be like, that's dope, I'm going to put a visual editor on the screen that shows you what all those things are, and I'll identify you by name, and your patch, what patch is active is going to be visible on the DAW and stuff like that. So that's actually condensing several of these things together. But the first part is capability inquiry, like, for example, do you speak MIDI 2? So you can connect a MIDI 1 device and a MIDI 2 device. They can try to do capability inquiry, and if the MIDI 1 device says, no, sorry, I don't do that, it'll default back down to MIDI 1. That's always your fallback. So any two devices can always do what they can do now unless they talk to each other and agree that they can do new cool stuff. Here it is. Association of Musical Electronics Industry is the Japanese version of the MIDI Manufacturers Association. Collectively, these two groups are made up of all the companies that make MIDI stuff, and they support the further development of MIDI and make sure that everything stays standardized. So the three parts of MIDI CI are profile configuration, property exchange, and protocol negotiation. What I was saying earlier about how USB MIDI can't go as fast as it technically could because there's no way to tell the device downstream how fast you're going to be throwing data at it. Protocol negotiation is the mechanism for dealing with that. You can say, hey, how fast can you receive data? And the device can say this fast, and then blam, they're off and running. And if that negotiation fails, then they default back to MIDI 1.0 rate, and we're where we are today. Okay, wait, there's probably slides for these. Hey, there are, cool. So profile configuration this is something that, again, like the Japanese companies that make combo organs and things like that are really about this. But it's basically a good concept. It's saying if a bunch of people make the same kind of thing, like a drawbar organ, like, you know, a trap kit controller, like a wind controller, or, you know, a model of an instrument that has standardized controls on it. Basically, the idea is if something can be described generically, like this is one of these, and these are the controls that it has, you can call that a profile, and you can take any generic controller and let, you know, a device, some tone generator that can make drawbar organ sounds can plug into your generic controller and say, hey, set me up like a drawbar organ. And your controller will have a profile for that. Everything just works, all your drawbars are mapped, all your controls are, you know, in sensible places. And so you don't have to like manually write scripts to configure your controller to work with some new piece of gear, because the piece of gear says, hey, here's how I work, here's all my controls. And so the idea is that that's really plug and play for, do you support drawbar organ profile? Yes, maps it out. And, you know, so we've thrown out some basic first pass ideas, like these are things that a ton of different people make really similar instances of. One of the ones that I'm most interested in, but a little daunted by, is the proposal for subtractive synthesis control, which is, can we make a generic profile that encompasses all of the standard subtractive synthesis stuff that you would do, like sort of a superset that would encompass like all the analog synths out there, for instance. And it, you know, sure, they have oscillators, they have mixers, they probably have envelopes and filters, but what do the envelopes look like? How many stages do they have? What do they have curvature? How many filters? How are they configured? It starts to get difficult. But there's the germ of a good idea in there. It would be really cool if you had like, you know, if any two synths that had two filters, filter one would be controlled by this controller, and this filter two would be controlled by this controller, and that way you could generically have a template that was definitely going to control the things you thought it was going to control in terms of filters, oscillators, envelopes. You know, so that's the idea. That's still it's like a working group. It's a proposal that's out there that nobody's actively working on, but hopefully we'll get to develop that. And there are other people who do things like voice to MIDI control, like, you know, you sing into a mic and it does real-time MIDI with pitch bend and stuff like that coming out the other side. That's something that's going to be a lot easier in MIDI 2 because of the per note control and, you know, per note pitch bend and things like that that you have, which I'll get to in a little bit. But so people that were working on gear like that are working on a fluid pitch and tuning profile, where the idea is that anything that lets you convert, you know, audio seamlessly into control data, you could have some common controls for the parameters that they all use to do that. And overall, the goal with profiles is to make it easier to interoperate, you know, different types of controllers with different models of things being controlled, where as a musician, you just hook them up and you do your thing and it sounds good and it works. And you like, each person doesn't have to maintain the tool chain of technology to make their controllers and their sound generators play together, which is basically what we have to do today, as a lot of you probably know, to your own personal cost. Okay, so property exchange is saying, okay, synthesizer, what parameters do you have? What's the range, you know, minimum, maximum? What's the default value? What are they named? And so a DAW can ask all of those things and have like a full representation of the state of a hardware instrument just automatically loaded in. And this lets you do a couple of really cool things. One of them is sort of a total recall concept where you can save the state of all of your compatible hardware in your project the same way you would save the state of a plugin. So, you know, your gear's hooked up, you're turning knobs on your hardware, you save all and close your software, and you reopen it, and all the tweaks that you were doing to your hardware were remembered because they're all known, and you know, all that information is shared back and forth. And because this is at a protocol level, like if they speak MIDI CI and they do property exchange, then you get all of this stuff with everything that, you know, you don't, there's not this development effort for each new piece of gear. It has to have a custom editor, and someone has to make art for it and debug it and maintain it. It's just like, if they speak this language, then, you know, your DAW is your editor for all of your things because the hardware that you hooked it up to told it so and told it all about it. One of the things that they're working on in Property Exchange that's very cool, it uses JSON, which is just a way of formatting data that's human and machine readable, basically. It's just a syntax for writing down stuff. And so within this, you can do a lot of things. And you know, HTML is kind of the same way. HTML is just a format for writing down stuff, and then that's been expanded and expanded and expanded to the point where you've got, like, you know, crazy VR happening on your web pages. Property Exchange is kind of going down the same route. Originally, the idea was, hey, you know, what parameters do you have, and what are they named, and what are their values? But by using JSON to define more abstract levels of stuff, one of the things that we figured out how to do is you can have the instructions for rendering a complete graphical editor come over the wire from your hardware onto your computer. So the hardware itself says, like, hey, draw me a window like yay big and put this filter graph on it and put these knobs on it, and these are the parameters that they control. And so you can embed all of that in Property Exchange and have your hardware tell some other device, you know, how to make an editor window for it. So that's pretty cool. Yeah, so you can get and set properties based on stuff I just said. This is not my slideshow. Thank you for your patience. Yeah, so protocol negotiation is how two devices handshake and say, do you speak MIDI 2, and which specific things within that do you support? Because you can make a device that only does certain of these MIDI 2 things, depending on, you know, not everything has to fully blown do everything. And this little box is labeled Next Gen Protocol, that is now officially MIDI 2.0. Yeah, so here it is. This is MIDI 2.0, the very, very basic introduction. I've got like a one-page data dump of all of the stuff that I could just blast through, but I thought maybe I would try to split the difference of, like, sort of trying to follow this and also sort of like moving ahead to the good stuff. But yeah, so MIDI 2 is shaped a lot like MIDI 1. It's based on a lot of the same concepts. You have all of the same things, but basically more of them. So you get higher resolution for your controllers. There are more channels simultaneously. Many more controllers exist. And for every note, they all automatically get per note, like, you know, every MIDI controller that you have, you get per note independence of those controllers. And the same with pitch. Like, every note has independent pitch that you can address directly. Channel pitch bend, but you're not limited to that. You don't need to, like, mess around with putting notes on different channels to have independent fluid pitch control. You just get that. Articulation control is like attack velocity is a parameter that exists at the start of a note. Articulation is another parameter that exists at the start of a note that can be whatever you want it to be. Like, let's say you've got some virtual frame drum. You can have a parameter for, like, where from the center to the rim you're hitting it, which is independent of how hard you're hitting it. So you get an extra note-on parameter, basically. That could be used for selecting samples from a multi-sample. There's all kinds of things. You know, it's a freebie. It's like, hey, sound designers, here's an extra cool thing that you can have, you know, control of it note-on. Tuning, there is the MIDI tuning standard. I think that MIDI 2.0 tuning is basically designed to do everything that the MIDI tuning standard can do, only a little bit more, you know, sensibly and compact. But that's one where also I think that it's not 100%, or yeah, I'm not able to speak exactly to the expanded tuning capabilities right now. But like, I think when I say simpler, RPNs and NRPNs are, in MIDI 1.0, they're a way of accessing 16,000 more controllers that are used in various ways. The NRPNs are available for manufacturers to define however they want. However, they're notoriously hard to use. Like people who use Dave Smith stuff, DSI mostly uses NRPNs for control. Most software doesn't just effortlessly let you use them. It's like, it's a process and it's fiddly. That goes away, and the same with bank and program change. All of these messages that have like multiple parts that have to be assembled correctly in the right order to do the thing that you intended them to do, and that like are notoriously hard to edit, all those just become single individual messages. And part of the way that works is that the message packet itself is larger. It's like a 64-bit packet that you can put different things in and tie them together. But so this is a little diagram of like the negotiation process of MIDI CI. So auto configuration lets you, you can auto configure profiles, do property exchange, do protocol negotiation between MIDI 1, MIDI 2, and even something manufacturer specific, like maybe for loading firmware or communicating in between two special devices. And again, it falls back to MIDI 1.0 if anything doesn't work. And you can also, there are rules for translation between MIDI 1 and MIDI 2. You can forward translate from MIDI 1 to MIDI 2 losslessly and perfectly, and there are rules for back translation that are like minimally objectionable. Basically, lose as little as possible. And again, okay, yep, that was the end of that slideshow. So let me go to the one-page big list of all the new stuff that's in MIDI 2, and we can just talk over the details right quickly. Yes, okay, so the MIDI 2 protocol specifically, so what I was describing earlier was mostly capabilities inquiry and property exchange. That's not the MIDI 2.0 protocol itself. This is like the actual MIDI 2 language, what is it and what does it do? And that's where, it gives you higher resolution parameter values, more channels, per note controllers, and so it uses this larger packet. There's a MIDI 1 packet on the top of that little diagram, and a MIDI 2 or MIDI 1 message and a MIDI 2 message. So you can see that it's longer, but it contains the same basic stuff in addition to a little bit of extra stuff. So you can always take a MIDI 1 message and put it into MIDI 2 format losslessly just by moving the data where it goes. So the MIDI 2 messages have a fixed packet size, and they're all either 32 bits or 64 bits. And you have high resolution velocity always in node-ons, and the new field for node articulation that I mentioned. You can also put directly in a node-on exactly the pitch that you want it to be. So instead of just saying this is an A1, you can say, this is 111.2 hertz because I want to be special with it like that, or because you want to define a scale on the fly. And then after a note is on, you can directly affect the pitch of any note that's already sounding as well with another message. So bank and program changes, just have one atomic message for as many banks and program changes as you want. I think, at least the same, 16,000 or some that you would get with all the extended MIDI 1 messages. So yeah, you've got brand new messages for per note control and for per note pitch bend. So for any note that's already been played, you can say, this note, I want to affect some property of the voice that's playing that note. And you can do that on the fly at any point in the life cycle of a node. Another thing that you get in MIDI 2.0 is it has an inherent time stamping as a part of its packets, and that's for jitter correction. So if you're going over a network and there's any kind of jitter or funniness about your network, if it's not 100% real time, you can timestamp all of your messages as to the intent of when you want them to be rendered relative to each other. And obviously the only way to get that is with a little bit of latency up front, a fixed amount of latency that's more than your jitter. But if you do that, then you can have perfectly jitter-free rendering on the other side at the cost of a little bit of latency. And the latency is going to be a lot less than Bluetooth or something like that. It's very small. Let's see. So additionally, things like sysx are a lot easier. There is, there's sysx in MIDI 1.0 is kind of brittle because it's designed to go over a single wire. It can be interspersed with other messages. There's not packets. It's just serial bytes of data, and so that worked great in 1983, but it has a lot of challenges that are not necessary in a world where you have network protocols that have headers and packets and ordering and things like that. So you can very much more easily ship lots of data back and forth quickly using this protocol, which is good for firmware updates. It's good for things like saving and loading the state of an instrument onto your computer, things like that. And also another of the main goals was expansibility. There are, as opposed to the 0 available opcodes for new messages to be defined in MIDI 1, there are still thousands of available opcodes in MIDI 2. So as new standards come together, new people agree that they want to do a thing a certain way, the same way, we can, there's lots and lots of room for expansion before you have to start doing the careful configuration and manipulation that you need to try to get anything new into MIDI 1 at this point. That is, I think, just about it for the MIDI 2. There was one more one sheet that might have been on, yeah, here it is. Okay, no, this is a recap of what was already in the slideshow. So that is the nuts and bolts of what MIDI 2 will be. I guess another thing that I could obviously talk about is when, like, what's the time scale, what's actually happening with this. So here's basically where that's at. The protocol itself, MIDI CI, the capabilities inquiry and the property exchange and that stuff, that was ratified in January at this last year's NAMM show. So that's official, it's published, it's out there, but there's not a whole lot that anybody can do with it yet because there are a couple of other pieces that are still in development. The rules for creating profiles, which are a part of it, and the rules for property exchange are basically done except for like one little negotiation about how the headers of the messages should look. And this is one of those things that's probably of immense importance, but it's like it's minute in its technical details. So they think within a couple more weeks they'll have that hashed out. At that point, the protocol is out for review for a vote. Everything in the MMA is done by consensus. It's actually like charmingly hippie-like organization at its roots. It's like very egalitarian. It's like they don't even want to vote on things. If they can help it, they would rather just talk it out until they can achieve consensus, and that's what it's about. So that's pretty cool. I support that. I think that's really awesome. But it does mean that things can take a long time because it's like things are done when they're done. The goal is to get them done, done for the ages and done right. And if it takes a long time, hey, oh well, we're volunteering our time, so you can just wait. But so that, on the one hand, things do move slowly. On the other hand, there's a lot of interest and a lot of people really pushing to get this to fruition. So the protocol was sent out for review for all the MMA members. We give them like 30 days to look it over and comment, and then we put it to a vote. So that vote is coming up in late April, I think, or early May. And that's the protocol piece. At that point, our Japanese counterparts, AME, also have to vote to approve anything that we approve before it's, official, before it's canon. So they're reviewing it now. And so there should be a vote on the protocol from both sides, AME and the MMA, by, midsummer, I would say. And then the rules for property exchange, probably by the end of summer. At the same time that all of this is going on in terms of like writing down standards and so on, there are a bunch of companies and a bunch of individuals out there prototyping, like actually making gear, making hardware and software that speaks the new protocol. These are the folks that were on the working group that had access to it before it was published. And so there's 10 or a dozen like there's a version of Reactor that speaks MIDI 2 already, and you can we'll host plugins that support it, and so you can pipe MIDI 2 in and out. We were working with Microsoft, we're working with Apple to get this stuff like baked in at the OS level. That part's going to take a little bit of time, but they're actively working on it. So I would say, by the end of this year, I think the whole MIDI 2 ecosystem will be pretty much together and everything will be finalized. it may still be a little bit of time before you start to see products out there in the world. Or it may not, because that's another one where there are people who are, I've seen, I guess it was Roland and Yamaha doing cool MIDI 2 tricks with existing hardware that they had. So I think that there will be a lot of people, like especially in the software world, if it's just a matter of flipping a switch, like, oh hey, turn on that MIDI 2 implementation that we've been debugging for the last 6 months. You might start to see some things pop up really quickly, and then in terms of like actual full-on hardware that's designed for the purpose, that's designed with this in mind, that'll probably be, maybe we'll start to see some next year, maybe it'll be another year out from that. But this is definitely the year where all of the pieces are going to be finalized and published and people can start putting it into production. Questions?
Do you think existing instruments like the instrument and the Rollies are reprogrammable to do this?
Definitely. I know for a fact, well, my colleague Kurt, that also works at Moog, also develops the firmware for the instrument.
Right.
And so it is field updatable and new features get added all the time. I'm confident that MIDI 2 features could be added to an instrument like, most or all these instruments. I would expect that.
Are we still using the 510?
No. MIDI 2 does, well, no by default, and the intention is to start with USB and then probably move to Ethernet as the second transport. This is a protocol, so it's transport agnostic technically. Semaphore would work, tin cans and strings would work very slowly, very noisily. There people have written papers about all this stuff, but USB is going to be the day one transport. Ethernet and internet generally would probably be the second one, but there will be rules for example, there's a rule for encapsulating MIDI 2 in MIDI 1.0 flavored sysx. In a standard sysx, you can make a sysx packet that says, hey, this contains a MIDI 2 message. And so you can very slowly and laboriously ship MIDI 2 messages over a 5-pin wire using that sysx encapsulation. But I don't think anybody's recommending that right away. I'm sure it'll solve all kinds of cool problems down the road, but it's not like, hey, look, you can do this. It'll be great. You had a question?
Yeah. I guess a very specific type of question. Are all the DAW manufacturers well on board with development? Are they moving towards this, especially Ableton?
Ableton is kind of a poster child for not supporting MIDI, I'm afraid.
Well, I know.
So I'm not going to look to them to be out on the forefront. Steinberg is actively involved. Yeah, they are like...
Cubase.
Yeah, Cubase is right up in the developer meetings, like saying, oh, we want it to do this or more of this. So like, yeah. So Cubase is probably, I would say, the Cubase and Logic would probably be the first two that'll be on board. Because we work really closely with the folks at Apple, and actually GarageBand. It would not at all surprise me if GarageBand jumped on board really quickly, because they started supporting MPE before almost anybody. Yes.
Is there a reason besides industry inertia that OSC never got picked up as a replacement for MIDI 1.0?
I've heard various theories, and a lot of people have wondered that. Industry inertia is one of them. I mean, OSC very much came from academia, so there were no real champions of OSC inside the MI industry at the time. They were all, they were 100% on board with MIDI, or they wanted to do their own thing. I have heard it said years ago now, what some of the specific criticisms were about OSC as to why, why it didn't replace MIDI.
Because 30 years of keyboards don't have it, that's why.
That is the number one, is the compatibility piece. But as to why people didn't push harder to build that compatibility, I think it had more to do with just how nebulous and generic and non-standardized it was. You could just kind of define, any kind of units and ranges and, which is great if you're if you're working on your thesis and you want to build some new crazy musico-electronic contraption. It's great for that. It's totally open-ended. I think it was too open-ended, too unstructured for, for people to push to put that into the music industry. And, it wasn't powerful enough and focused enough to supplant 30 years of MIDI. because that wasn't what it was designed to do. Anyone else? Yes.
So is MIDI 2 going to be like capable of, say, instruments that didn't have or like are a little bit like 90s to 2000 kind of range? Is that going to give the ability to actually see information from them that's like what the MIDI 1.0 is sending to, or basically like able to do with MIDI 2.0, or essentially give you an outlet of like what all of its functions are?
Not directly, unfortunately. There's no way to imbue the actual piece of hardware with any new ability to say things it couldn't already say about that stuff.
Give it a new ability, but more or less see what its abilities are.
Well, no, that's a case where
if somebody set up a profile for that instrument, then you could do that.
Yeah, that's exactly it. There's a framework where you could someone could manually program a profile describing that instrument, and it would tell you, like, for example, everything that wasn't changeable about it, like these are the parameters and these are the values and these are the CC numbers. You could write all that into a profile. And there are like, I think you can do that inside like Cakewalk and things like that now. There's like, you can create an instrument definition that does that stuff. But so there would be a way to do that, create an instrument definition in the form of a profile.
So community driven at that point?
We're looking at how that's going to work. Once at a certain top level there's going to be a level of officialdom of profiles that are like, these are officially blessed profiles that have, been reviewed by people who care about these things and they're totally kosher. I think that there will, in addition, be some way to do like, user-generated ad hoc, like, hey, I made a profile for my piece of gear, here it is. But those would be like distinct from each other, so that you would, so that the, like developer versus manufacturer level of specificity or rigor or something like that. The short answer is yes, we for sure want people to be able to submit new profiles. The mechanics of how that's going to happen have not yet been worked out. Probably something on like the MIDI.org website, like like a submission template or something like that. And so yeah, once that existed, you could have all of your parameters. The only thing you couldn't do is like, what preset do you currently have, and can you send it to me? There wouldn't be a way to add that to a MIDI 1 piece of gear.
For like an MPC, for instance, it'll be like, here's how many pads you have, here's the effects that you could actually control, and
yeah, anything that is a defined part of how the machine works that's not subject to user editing.
Cool.
Yeah, you could define that as a profile. Yes, sir.
Is there a so-called leader of the MIDI group? Like, who really like drives the car? No.
Well, technically, I'm the chairman of the Technical Standards Board, so I'm that to a certain extent. But there are a lot of other, there's an executive board of the MMA that's other people that do more of the biz-related stuff. Then there's like, who has the money to pay engineers to do work, and to a certain extent, those people drive what's going on because their agenda is, at least in part, manifest in the people that they hired to do some work for them. So like the development of MIDI 2, part of it is, some of it is people who are genuinely volunteering their time. Some of it is contractors basically who are hired by Yamaha to develop this specification, because Yamaha has a vested interest in the specification existing, so they're going to pay a guy for his hours. That's not to say that Yamaha has some sinister motive and they're like twisting the spec in some weird direction. Like, they want the same thing that everybody else wants.
Sure, yeah.
But the specific formulation of how they want that is likely to be manifest, because they've got the ear of the person who's writing down the specification. Even though that person is working in a group with other people and there's a free exchange of ideas, I'm a burner, so like it's kind of a duocracy. If you have time and you do something, then you're in charge of that thing.
So when MIDI 2 sucks, we come see you, right?
Yes, actually, technically, that is correct. It will not have been my fault, but I'll know who to talk to. All right, I'm open to other questions. I can keep yakking up here, or we can move on and look at some other cool stuff.
Do you
Yes.
have a framework to do like iterative updates within the MIDI 2 framework? Is there sort of a process?
Yes, yeah, there is. There's a working group, basically. There's a protocol working group, and they, the result of their efforts cumulatively is going to be version 1.0 of that protocol. But anybody who's a member of the organization really is free to join the working group. And if they say, hey, I'm working on a use case that isn't solved, and here's how I propose that we fix it, the working group can look at that and be like, okay, yeah, that works. And then that gets adopted. And if it's something that actually changes the specification itself, then we'll release a 1.1 spec and send it out to the members for review, and they'll vote on it. And if everybody's cool with it, it becomes official, and then it's version 1.1, and that gets posted on the website and distributed.
Standard software.
Yeah.
Okay.
Yeah. It is a standards body, and it works like a lot of other standards bodies with all the bylaws and the voting and the things.
Politics.
Yeah. But most importantly, version numbers that get updated and new docs that get published.
Cool.
Yeah.
Thanks.
And those are all available on MIDI.org.
Okay.
And pretty much every MIDI spec that exists now, you can go there and get it for free.
All right.
Yes.
Yeah. Is there any protocol, sub-protocol, or anything new in with regard to synchronization between machines, either maybe fundamental in note exchange or tuning and/or key signature? Is there anything like that in 2.0?
When you said synchronization at first, I thought you meant time synchronization.
Time, right? But I mean, we've got that.
Yeah.
We have clock and we have master sync, but is there anything with regard to key, either that or fundamental frequency for tuning and/or signature?
Yes, you can, for every MIDI note, you can say, this is the frequency that I want you to play in response to this MIDI note. And I believe I don't think there are any living examples of exactly what you're asking for yet, but my understanding of the protocol is that one machine could say to another machine, hey, here's a tuning table, here's the frequencies that we want you to play for all these notes. And the other machine could be like, cool. And then they would share that tuning data. That tuning table would be what was active for that instrument. Yes?
To how many decimal places on the tuning?
I'm not 100. It's going to be no worse than like 1/81/92 of a semitone.
Okay.
So you'll have at least 8,000 increments per note.
A lot.
A lot. And again, it's probably more than that. I'm taking that from the MIDI 1 tuning standard. So if you take a semitone and you say, I've got 14 bits of data to get me from this semitone to the next semitone, that's your resolution. That gives you like 1/8,000th of a semitone. No, actually, wait, it's more than that.
65,000.
Yeah, sorry. There's two different tuning standards, actually. There's a 1 byte and a 2 byte one. Yeah, so in short, better than most people can hear and better than most analog synths can be tuned to precision-wise. Good enough.
Cool.
All right, this may possibly conclude my presentation of the MIDI 2.0 protocol. Thank you very much.
Hey!